So in today's lesson, students will be able to add and subtract numbers in scientific notation. So this I used to explain better when we had to cover what happens if the exponents were different. However, good news is for 8th grade, you just need to know how to add scientific notations when the exponents are the same. So I don't need to really go over this so much because I'll make it more complicated than I have to. As of 2010 census, the population of Wyoming was approximately 5.63 times 10 to the 5th power. The population of Vermont was approximately 6.25 times 10 to the 5th power. Find the total population of the two states. And then B says, find the difference in population for the two states. The word total, right? You learned this since elementary school. The word total means to add, while in B, the word difference means to subtract. I'm going to show you right now in this one example how we add and subtract scientific notation. So when we add scientific notation, it's going to be 5.63 times 10, actually I have an idea, times 10 to the 5th power, make it a little Christmas theme right here, plus 6.25 times 10 to the 5th power. So whenever you're adding scientific notations, try to think of it like fractions. So over here, I'll just do like 5 over 3 plus 7 over 3. You do not need to solve this. Just listen. When you add fractions, right, your denominators have to be the same in order for you to add them. Once they're the same, then all you got to do is add the numerator, so in this case it would be 12, and you keep the denominator alone. From there, you reduce it, right? The answer would be 4. But once again, the basic version of this is you first check to make sure your denominators are the same, and then you add the numerators and you keep the denominator. This is the same thing. Notice how your exponents are exactly the same. I got to make it clear. You can only add scientific notations if the exponents are the same. If they're different, you cannot. So because they're the same, you leave it alone, just like you left your denominator alone. So my answer is going to be times 10 to the 5th power. I leave it alone. I leave it alone. And then I simply just add my a's. So I add 5.63 plus 6.25, and I get 11.88. Now there's only one problem with this, and I'm going to have to make a little bit of room here, and I'm going to move this over here. Everything I did was correct. Unfortunately, they want my answer in scientific notation. But remember in 2.1, your A, and this is your A, has to be between 1 and 10, where it can equal 1, but it has to be slightly less than 10. 11.88 is bigger than 10. So what we have to do now is we have to modify it. We have to tweak it a little bit. What we got to do is take our scales from 2.1. So you see this times 10 to the 5th power, just bring it down. From there, we're going to put the decimal in between the first two numbers so that it's in between 1 and 10. And my new number now is 1.188. But now it's times 10. And how many spaces did you move it from the old decimal to the new decimal? You moved it 1 space. So it's going to be 1.188 times 10 to the 1st power. And then you bring down that times 10 to the 5th. Then don't forget what you learned in chapter 1. When you're multiplying the same bases, what do you technically do with the exponents? You add. So my final answer is 1.188 times 10 to the 6th power. Now that's the way the textbook explains it. I have one more way of explaining how to tweak it that might be a little bit easier. So I'm going to go back to the original answer that we had. So originally we had the 11.88 times 10 to the 5th. A lot of students said that this way was easier for them to comprehend. So I just wanted to show it to you. Once again, this was the textbook way. This is the way I would recommend. Let's just say you get 11.88 times 10 to the 5th power. Once again, you do need to tweak it. You do need to put it in scientific notation. So you do need to move this decimal 1 space here. Because you went and you moved it here, now it's 1.188. From the original number to the new number, did it increase or decrease? It went from 11.88 to 1.188, so obviously it decreased. The value went from 11 to 1. Just think of it like that. So in order to offset that, you have to then increase the exponent 1 higher. So then it'll be times 10 to the 6th power. If you increased your A, then you have to decrease your N. So that's just one other way of doing it. Moving forward, I'll try to explain it both ways, and you decide the way that works for you. And now let's get the difference. Now understand, you're talking about population. So normally I tell you to read it like a book. Whatever number you read first, you put first. But obviously, even though you read this number first and this number second, because you're talking about population, you can't have a negative number. So we have to put the 6.25 times 10 to the fifth power first, and then minus 5.63 10 to the fifth. Your denominator, right, is the same, quote unquote. It's really your exponents, but I just want you to tie it back into your fraction rules. Because your exponents are the same, because your denominators are the same, you leave it alone. So my answer is times 10 to the fifth power. Done. And then all you're going to do now is you're going to subtract your a's. So you're going to do 6.25 minus 5.63. Then you get 0.62. Once again, though, even though you're solving this correctly, think of it like you have to simplify fractions. Sometimes you do it, sometimes you don't have to. Sometimes you can't simplify. Here, sometimes you're done. After this, you don't have to do anything, but your answer is not in between 1 and 10 like it's supposed to. So you have to tweak it. You have to modify it. I'm going to try the second way now, and maybe this will make more sense. So in order for me to make A, and this is A once again, in order for me to make A a number between 1 and 10, I got to place a decimal here. So it's technically 6.2 times 10. Now, from the old number to the new number, I increased it, right? It went from like 62 cents to $6.20. So I made the A bigger. So to offset that, I have to make the exponent 1 lower. So instead of it being 5, it's going to be 4. My final answer, 6.2 times 10 to the fourth power. Now I'm going to re-explain it the first way, the textbook way, and I want you to obviously decide the way you want to do it. You have 0.62 times 10 to the fifth as your answer. The textbook way is just taking your skills from 2.1. Don't worry about this for now. You want to convert this into scientific notation. So you got to place a decimal here. So it's going to be 6.2 times 10. But remember, the original number was smaller than 1. So it's going to be a negative exponent this time. And you move the decimal 1 space. So it's going to be 6.2 times 10 to the negative first power. Then you're going to bring down your times 10 to the fifth power. Then you're going to take your rules from 1.1, where when you're multiplying the same bases, you technically add the exponents. And you get 6.2 times 10. And negative 1 plus 5 is positive 4. Same answer as I got up here. Whatever works for you works for me. I definitely understand how this might seem more confusing, but to be fair, you already learned all this. You're just putting it all together, right? You're taking skills from 1.1, you're taking skills from 2.1, and you're applying it all together. But I still understand how that can be very difficult. This is just a quicker way of doing it. You're pretty much doing the same thing, and you're using a visual to help you understand if you should go one higher or one lower. All right, so try these two on your own. The good news is, I'm pretty sure you don't need to tweak either one of these answers. Once you add and subtract, you're going to get a number that's already in scientific notation, which is good. All right, let's go ahead and do this one together. This time we have negative numbers. The approximate thickness of a standard CD is 1.2 times 10 to the negative third power meter. A slim jewel case is about 5.3 times 10 to the negative third power meters thick. The CD is placed on top of the jewel case. What is the total thickness of the CD and the jewel case? Total means to add, so we're going to add these two. So it's going to be 1.2 times 10 to the negative third power plus 5.3 times 10 to the negative third power. Okay, first things first, we're going to keep our times 10 to the negative third power. Once again, like adding fractions, you keep the denominator alone once they're the same. So you leave it alone because they're the same exponent. And you're simply going to add your a's. And you get 6.5. Now, I got really good news for you. 6.5 is between the 1 and the 10. That means here, it's already in scientific notation. You don't need to do anything. You don't need to tweak it afterwards. Okay, letter B, how much thicker, right? How much thicker is the jewel case than the CD? So that means subtraction, right? So how much in the future, always know that means you're going to subtract. But you're still talking about distance, so you can't have a negative number. So that means that the bigger scientific notation has to go first. So it's going to be 5.3 times 10 to the negative third, not adding this time, but minus 1.2 times 10 to the negative third. Your exponents are the same, so leave them the same. So leave the times 10 to the negative third power, and then you're simply going to just do 5.3 minus 1.2, and you get 4.1. Final answer is 4.1 times 10 to the negative third power. Again, here, your A, that means the number that's in blue. Your A is between 1 and 10, so you do not need to tweak it. So you need to understand when you need to tweak the problem and when you don't need to. Right now, this answer is already in scientific notation, so you're done. Okay, try these two on your own. Okay, example 10, you're going to do on your own as well. All I'm going to tell you is the word sum means to add. So you're going to add your scientific notations. But if you notice, this number is in scientific notation and this one's not. You can convert this guy into standard form and then add like you normally would. It doesn't tell you that the answer has to be in scientific notation. So just understand, read this to yourself first, and then when you find the sum, when you add, just make sure you're adding an apple with an apple. Either make both of them standard form or make both of them scientific notation.